Hello, thank you, Moni. Hello, everyone. My name is Siqi Huo. I'm the chair of the first section, and today the first presented is our presenter is our PhD student Yong Guo. His research is focused on the exploration of structure performance relationship of the flame-retardant recyclable bio-based vitrimers and their application in carbon fiber reformed polymer composite. And today his presentation topic is recyclable flame-retardant bio-based thermosets from molecular engineering to performance and application. Now, welcome Yong Guo and hand over to you.
Okay, thank you for inviting me to have a presentation to share my research here. I just finished my COC in this year on February, and just accept my review. So I think it is a good chance for me to share my research for all of you guys. My name is Yong, and my supervisors are Prof. Hawang, Dr. Sti, and Prof. Ping. And today, my topic is about a recyclable flame-retardant bio-based thermosets from molecular engineering to performance and applications. Today, the part 1 is introduction, part 2 is little review, part 3 is challenges, part 4 is opportunities. Next. Today I will focus on introducing the carbon fiber reinforced polymers CFRPs, and this will be appeared on this presentation many times. Probably the CFRPs is consistent of the polymer such as the EP and the carbon fiber CF. Next. As we all know, the CFRP has lots of advantages such as high strength to weight ratio, excellent corrosion resistant, fatigue and creep resistant. Next, thank you. So it can applied in everywhere such as the aerospace series, automobile industry, sports equipment, and wind power generation. So the global CFRPs are expected to produce about 127,500 tons in 2025, and the Australian automotive composite market is expected to grow over 7% in 2025. As we all know, I mentioned that the CFRPs consist of the polymers such as DGBA. However, the problem is that basically all of the commercial epoxy resin is sourced from the petrol-based. Especially for the bisphenol A, it can cause healthy hazards. So, what can we do? The best solution is to use the bio-based feedstocks to replace the petrol-based. As we all know, the CFRP consists of the DGBA and carbon fiber CF I mentioned before. Because of the DGBA possessed lots of hydrocarbon structure, is caused the DGBA flammable seriously. Additionally, the CF possessed the properties of the thermal conductivity. So, because of the candle-wick effect, the CFRPs is extremely flammable. So, what can we do? Recently, research focused on using the phosphorus halogen containing flame retardant to insert in the epoxy resin to achieve the performance of the flame retardancy. As we mentioned, the CFRPs is consist of the DGABA and the CF, and the DGABA paired with the current agents such as the IPDA, D230, DDM, and MPPHA, and with the CF to achieve CFRPs. However, because of the unrecyclable permanent cross-linking structure of the epoxy resin, so the traditional CFRPs is unrecyclable. So what can we do? Recently, research focused on introducing the dynamic covenant industry into the CFRPs to receive the recyclability, and typically it divides two types. First one is the dissociative exchange, such as the DA reaction, and the second one is the associative exchange, such as the transesterification, cell bond exchange, image exchange. Next one, I'd like to introduce some little review. First one is the DA reaction. The authors used the bio-based monomer DGFA to combine with the phosphorus flame retardant structure to achieve a phosphorus containing DA-based epoxy resin and applied on the CFRPs. And the bio-based carbon content of this DA-based epoxy resin is 28.6%. First one, this system achieved the flame retardancy, such as the TSB decreased 56.6% compared with the commercial epoxy resin, and the CFRPs decreased 41% of the THR with the commercial CFRPs. And the mechanical properties enhanced compared with the commercial one. Last, this system achieved the repairable and recycle of the CF. Next one, I'd like to introduce the transesterification. First, this system used the bio-based curling agent to curl the commercial epoxy and with modified. This modified possessed the primary hydroxy to faster the transesterification between the dynamic eastbound to achieve the bio-based flame retardant and recyclability. This system possessed 31.6% bio-based content. First, the original and recyclable CF EP both possessed excellent flame retardance with AOI of 36% and UI9 for VO level. Second, it possessed excellent mechanical properties, such as the flame flexural strength. And it received the close-up recycle of with the CF, and we can see from the ribbon the structure of the CF is contained, and from the SEM of the recycled CFs, the CF is very clean. Next one, I'd like to introduced the imine exchange. Firstly, the author used the bio-based violin to react with the amine to receive, and with the epoxy reaction, to receive a amine containing epoxy resin. This system contained bio-based carbon content of the 40.3%. First, it achieved the flame retardancy from the UN94. Second, it possessed increased the mechanical strength compared with the commercial. Finally, it achieved the close-up recycle of the CFI piece. Next one, I'd like to introduce the challenges based upon my review. First one is the low bio-based content and high cost. Second is the trade-off between fire retardancy and other properties. Third one is depends on petrol-based cooling agent. The last one is the weak dynamic covalent bonds. Most DCBs have low bond energy, leading to unsatisfied mechanical properties and the durabilities of these recycled bio-based thermosets. So what can we do? I think we have those opportunities, such as first one is innovative screening methods for selecting bio-based raw materials. Second is exploration of strictly flame retardant structure from nature. Third is utilization of bio-based cooling agents. Let's develop stable DCBs. More efforts should be put into developing new DCBs that can only undergo bond exchange under specific stimuli. I just introduced some content with my review. I recently accepted my review. So if someone have some interest on this project, so you can download my review and see it detailedly. Thank you. Thank you for listening. Thank you for only.